Example 9, water flows in a 300 millimeter diameter pipe in a turbulent manner. The centerline velocity is found to be 3.6 meters per second, while at 85 mm from the centerline of pipe, the velocity is 3.2 meters per second. Estimate the flow rate, determine the head loss in a distance 300 meters, and what is the shear stress at the walls of pipe. So again, we use the velocity equation at any distance r from the center line. Vr equals v sub c minus 5.756 square root of tau max over rho log of rho over rho minus r. This is replaced by its equivalent v square root of f over 8. So Vr is at distance 85 mm from the center line is 3.2. So 3.2 equals 3.6 minus 5.756 v square root of f over 8 log of 150 over 150 minus 85. So we can compute this, combine the constants here. So 3.2 equals 3.6 minus 0.7391 v square root of f. So 0.7391 v square root of 8 square root of f is 3.6 minus 3.2, so 0.4. So from here, we can solve v square root of f, 0.4 over 0.7391, and that is 0.5412. We then use v sub c, centerline velocity equals v quantity 1 plus 1.326 square root of f. Then distribute 3.6 equals v times 1 plus 1.326 v square root of f. And v square root of f is 0.5412. So from here, we can solve for the mean velocity. 3.6 minus 1.326 times 0.5412, so 2.882 meters per second. So the discharge can now be computed. Pi radius 0.15 square times 2.882 area times mean velocity. So 0.2037 cubic meter per second. That's the discharge. The head loss in a distance of 300 meters. So first, let's solve for f, and head loss is 0.0826 FLQ square over diameter to the fifth by Darcy-Weisbach formula. So v square root of f is 0.5412 and v is 2.882. So f therefore is quantity 0.5412 over 2.882 square, and it is 0.03526. Substitute HF equals 0.0826, friction factor 0.03526, length 300, discharge 0.2037 square over diameter 0.3 to the fifth. So the head loss can now be computed, 14.92 meters. Finally, for what is the shear stress at the walls of pipe, that's the tau max, and it is specific weight of water, head loss, diameter over 4L. And the other formula is friction factor, density, velocity square over 8. Now, I want you to use this to check if they are equal. I just use this formula here. So 9,810 times 14.92 times 0.3 over 4 times 300. So tau max is equal to 36.59 pascals.